Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Moses Maudu, and this lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. So today we'll be looking at paper 2, revision, and where we are going to look at how to score easy marks in our paper 2. Remember, the paper 2 has the following topics, and I've also indicated the mark allocation or the weightings of those topics. The first one is analytical geometry at plus minus 25 marks, and we're going to look at analytical geometry and see how we're going to get easy marks. We're going to look at the easy marks, how to get those easy marks out of 25. The next topic is the trigonometry, which carries 50 marks. We're also going to look at how we're going to get at least from 50 marks, we can at least get up to 30 marks minimum. There's circles, angles, and angular movement that we have done. We've allocated 2 sessions for that, and we've already done that. And then I'm not going to be looking at this topic today. So I'm going to look at the analytical geometry and the trigonometry, and also part of the Euclidean geometry, which has 40 marks. So we're going to look at that and see how we can get marks from that, so then we are able to can pass this paper. Right, now, this, I've taken them from the examination guideline, of which I trust that your educators have given you this exam guideline to check what are the things that are going to be asked in the exam. First of all, in analytical geometry, when looking at the analytical geometry, we are going to look at how do we calculate the distance. So you'll see in questions that we've been doing, you'll see that we need to calculate the distance between the 2 points. The other thing there will be the gradient. So those questions will always be there in an analytical geometry question paper. So we need to know understand how to calculate the gradient of the line joining the 2 points. The next thing there is the coordinates of the midpoint also. So you realize that you have the formula sheet which has got all these formulae that I've talked about now. So always check your formula sheet so that then you get to write the correct formula. The next one is the equation of the straight line, of which most of the time we find that they ask this question, they base this question on the tangent of a circle, where they ask you how to find the equation of the tangent. So, tangent is a straight line, so you must understand how to find the equation of the straight line. The other one is the equation of the line through one point, where the lines parallel or perpendicular to a given line. So these are some of the questions that are asked in the topic. The next part there is the angle of inclination. We must also know how to do that. So when you're doing this paper that I've picked, you'll realize that these type of questions are there in the question paper. The equation of the circle with center at the origin 0 and 0, we must always understand how to do that. The equation of the tangent, I've already talked about that. The points of intersection of the circle and a straight line. So that's where you equate the two, or you use the simultaneous equation. But when you're talking about the circle and a straight line, obviously there will be the simultaneous equation, which we know in question 1, we always get that type of question. The last one there will be plotting the graph of an ellipse. So this is 3 marks. We will see when we're doing these questions that this question, it comes each year, and we must know how to draw, how to plot this graph. And right. Now let's look at the exam questions that we've prepared, and I've taken this from the past paper. So let's see how, and I've also indicated the marks there. So you can see if it's 2 marks, remember it's 1.2 minutes per mark. So it's going to spend about 2.4 minutes to do that question. But for now, because we are practicing, then we need to understand. So if you look at what we have done there, the question says you have got a quadrilateral with the vertices. On those vertices, you must read the question and make sure that the information that is on that question, it's also indicated on the sketch. In this case, yes, it's indicated on the sketch. Sometimes we find there's an information there, but it is not indicated on the sketch. We need to then take that information, indicate it on the sketch. Now they say E is the midpoint on PQ. Yes, we can see that E is the midpoint of PQ. The angle formed by PR in the positive x-axis, it's theta. So that angle that is from there will be theta. So the angle is also indicated. It is between the x-axis, positive x-axis, and the line PR. Okay. The first question says determine the gradient. So you realize on the examination guideline they said we must be able to calculate the gradient of the line given the 2 points. So sometimes we're given these lines that are parallel or the lines that are perpendicular, must also know how to calculate the gradient of those lines. So in this case, now you go to PR, and these are easy marks. This is just the first question on your question paper, on the question paper that I've picked, and the 2 marks we must be able to can get it. So we go straight to our formula sheet and we get the formula for the gradient, and from there we look at our points which are given. In this case, it's point P, and I'm also given point R. So if I check these 2 points, the P is given there, -2 and 2. The R is given at 6 and -2. I just need to substitute it into my formula. There is no way that I can get 0 on this question. I must get it right because the formula is there, the points are there. I just need to substitute and get to the correct answer. And make sure that you substitute correctly. So how am I going to substitute? I'm going to say the gradient of PR, it's equals to, remember, it's going to be the y-coordinated P minus the y-coordinated R, and you must copy it correctly, and x-coordinated P minus the x-coordinated R. And we have seen when we are marking that you guys are then writing it in the other way around. You are saying x2 minus x1 divided by y2. It cannot be. It must be the change in y over the change in x. These are marks that we must get. We must make sure that our formula is correct, and then from there we copy it correctly, then we substitute correctly. So in this case now I can say what is my y value at P? So I go to my P, my y value at P is 2 minus, and my y value at R is going to be -2. You see the first minus will be for the formula. The second minus will be for the coordinate there. The x at P, it's -2, and the x at R is going to be 6. So therefore, I'm going to get a 4. From here, please, you can use a calculator. Okay, please use the calculator to do that. Just put it on a calculator so that you don't make mistake. You're very sure that that answer is correct, and you put it as it is. Then, because you messed up, you substitute correctly. You messed up when you are adding and subtracting. Use a calculator from here. Then, in this case, there I'm going to get a -8, of which my gradient there will be -1/2. So the gradient of PR is going to be -1/2. How do I know I'm right? Because the gradient, that line there, the gradient is decreasing. The line there is a decreasing line there. So it means that the gradient is correct because it's negative. Okay, right. So now the next question here, the same question. So remember, whatever you've got in 1.1, then you can use it in 1.2 if it is needed. In this case now, they're still talking about the line PR, of which I know the gradient. Now they say theta is the angle of inclination of PR. So in other words, I must get the value of theta. And how do I get the value of theta? Inclination is an angle. So in other words, here is my theta, it's an inclination there. So I need the equation, I need that angle there. So remember, how do I get the angle? It will be the same as the tangent of theta. It's equals to the gradient of PR. In this case, because the line there, it's PR. So the tangent of theta, it's equals to m, the gradient of PR. And why the gradient? Because remember, tangent uses the x value, the y value over the x value. So remember, in trigonometry, is the y changing y over the changing x for tangent. So that's why we use the gradient. So the gradient there, we know that the gradient that we got is -1/2. Okay, so now we need an angle. So remember, we go to our calculators. Make sure that you know how to use a calculator. If you don't know, please ask your teachers and ask your fellow learners there. How do I then get to theta? So I go to shift and I press tan and then I press half. Please do not press -half. I'll tell you why just now. So if I press half there, so the angle that I'm going to get there, it's 27 degrees. It's approximately 27 degrees. And I call this a reference angle. Why? Because I can see that this angle here, it's more than 27 degrees. It's even more than 90 degrees. So meaning that it's an angle, it's an obtuse angle. So it cannot be 27. So how do I then get my angle? I'll then say, okay, go to my reduction formula, and I'll say 180 degrees, it's in the second quadrant. I subtract the 27 degrees, which is a reference angle. Then the angle that I'm going to get there will be 153 degrees. Okay, that is my correct angle. So you can see that it's 3 marks there, so you'll get a mark for that. You'll get a mark for the reference angle and a mark for the final answer. So if you stop at the reference angle, you'll only get 2 out of 3. So you must know how to do that. Because if you put a minus on a calculator, you're going to get a -27 degrees. And then from there, if you want to subtract the -27, then you get an angle which is more than 180. And you can see that that angle is less than 180 degrees. Okay, unless if your teacher has taught you that if you get a negative angle, then you just add the 180 degrees. Then you're going to get 153. But please, let's do it correctly there, because we know we don't work with negative angles in technical maths. Right, 1.3 there is still the same question. It says determine the length. So can you see everything that I've said in the exam guideline, which is a very important document? In the exam guideline, these questions are there. You see, when the examiners are sitting there looking at the exam guideline and say, how can we come up with a question that talks to the exam guideline? So now, here the length, we have talked about it in the exam guideline, the length of QR. So now I go to my sketch, I look for QR. Do I have all the points? Yes, I do have all the points for Q, the points for R. So how do I then get the length of QR? So remember, you go back to your formula sheet. On a formula sheet, you're going to get a formula for the length, for the distance, the length and the distance, same thing. So now I'm going to then say this is going to be the square root of. So if I need QR, I put the square root of. In the formula sheet, you find that it's QR squared, it's equals to there. But because I need QR, I must put the square root of. So now I go to my points. Write the correct formula, and then from there I go to my points and there. So I'm going to say, okay, for that it's going to be 0 minus 6 squared. So remember, it's going to be my x1, x at q minus x at r. Then plus, it's not a minus. Go to your formula sheet, check the formula and write it correctly. So this one is going to be minus 4 minus 2 all squared, which is minus 4, the y value there, and the y value there. So it's minus 4 minus 2. So I'm going to get a 36. So that should be a plus, sorry. Because that one was a minus, so it's minus, so it's a plus. So I'm going to get a 36 plus a 4 inside the square root. So I'm going to get square root of 40, of which I can also write it as, the question was leave your answer in the set form. So set form meaning that I don't need decimals, I need my answer inside the square root. If they've said simplest set form, then it means that I can go to my calculator and try to get that. If I press square root of 40 and I say equals to, it gives me 2 root 10. Okay, so this is just 2 marks. So how do I mark that? It will be 1 mark for the substitution and it will be 1 mark for the final answer. Because from here, from there, you can go there if you're using a calculator. Okay, so you don't need to do that step here. So if you're using your calculator, substitute, then immediately write down the answer when you're using a calculator. Okay, so these are easy marks. So you've seen that we now, and this, it's formula. I've used formula only. The first one I've used the gradient formula. The second one I've used the tan theta equals to the gradient. The third one I've used the length. So those formula are there in the formula sheet. And the points are there on the sketch. Okay. Calculate the coordinates of E. What were we told there? We were told that E is the midpoint. You see now. And that question also is also there. Midpoint, there's a formula for that. So you use your formula to do that. So my formula, so for the x point, then I'll have the x at P plus, it's not a minus. As I say, go to your formula sheet and check. Very important. Because sometimes we just write this formula and then from there we write them out of our heads. We think we know and then we mess up. So it's x at P plus x at Q divided by 2. That's for the x for the x value. So I'm going to then get x at P, it's minus 2, x at Q, it's plus 0, and that is divided by 2, and then I get my value there, which is going to be negative 1. That's that's the x value of the coordinates of E. So the y value there, I'll do the same, and then from there for the y value, I'm going to get a 2 plus minus 4, which is minus that. Then that is divided by 2. So it will be 2 plus minus 4, and then I get that. Then from there, I'm going to get a minus 2 all over 2, which is going to give us negative 1. So then I write down the coordinates of E. So the question says, determine the coordinates of E. I must not leave my answers there. So I must write that as coordinates. So I'll have negative 1 for the x, negative 1 for the y, then I've got E. So I go to my sketch there and I check. You see, that's how I can check whether I'm right or wrong. So that could be a negative 1 here. That could be a negative 1 there. So you see, then I know I am correct. If my points are something else, then I check it on the sketch, it doesn't match, then I need to go back and check my calculations and see that that is correct. So you must make sure that whatever you got in this, especially in this topic, then you are able to check it in the sketch whether that answer makes sense or not. Because if I've got minus 1 and 1, it will not make sense, because minus 1 and 1 will be somewhere here. So it cannot be a point E. So we need to check that. So these 2 marks, it's for this and that. Obviously, I can do it without working it out. So I can just go minus 2 plus 0, it's minus 2 divided by 2, it's negative 1. 2 plus minus 4, it's minus 2 divided by 2, it's negative 1. Just write down the answer and then you get the full marks. Okay. All right. 1.5, very, very important. Can you remember this again? The equation of SR. Let's check SR now. SR is a straight line. You see, it's a straight line. So meaning that is the equation of the straight line. And you go to your formula sheet, you get the equation of the straight line. But there's extra information that is being given. That this line PQ here, it's parallel to this line. So this line here is parallel to that. What do I know? First thing that I know, what do I know about parallel lines? They've got the same gradient. So it's the same gradient. So if I know the gradient of PQ, it means that I know the gradient of SR. Then I can use just that point. I can see this point is not given. You see, there's something missing in that point. This y value is not there. So I cannot say I want the gradient of that line. But that information, it's a hint to say, here's the hint, use that hint to do that. The hint is that this line is parallel to that. Now, how do I get the equation of that line? First, I must get the gradient of PQ. So if I get the gradient of PQ, then it means that I know the gradient of SR. Then I can use the formula. That's why it's formats. So the gradient of PQ, it's going to be 2 minus 4, it's 6. 2 minus 4, it's 6. And then minus 2 minus 0, it's minus 2. Then the gradient of that will be negative 3. So the gradient of this line here of PQ is negative 3. So meaning that the gradient of SR will also be minus 3 because they have got the same gradient because they are parallel. So I can then say, therefore, the gradient of SR is also negative 3. So I've got the gradient of SR. I need a point. So the point that I'm going to use is that. So then I'm going to use a point R, which is 6 and minus 2. So I've got a gradient and a point. Then I can use my y equals to mx plus c. My m is negative 3 plus c. Then this point here is x and y. Substitute it there to get my value of c. So my y value is going to be negative 2. Then my x value there is going to be a6 and then plus c. Then my c value is going to be 16. Then I can write down my equation y is equals to, remember they said we must determine the equation. So it's y is equals to negative 3x plus 16. How do I know I'm right? I know that gradient, that line here, that the gradient of that line there, you can see it's a negative gradient, it's decreasing. And then this line goes there, and then there, it will pass at 16. If I continue with that line, it will pass the y value at positive 16. So I know I am correct. Okay? All right. So now how do we mark that? That will be the gradient of that will be given a mark. Okay. So now you'll get a mark for that, and the mark for the substitution, and the mark for the gradient of SR. Knowing that the gradient of SR is negative 4, so it's negative 3, will give you a mark. So you must indicate it. Okay, right. Okay, let's go to the next one, 1.6, and you can see those questions are based on the same sketch. So whatever answers that you're getting, you can put them on the sketch so that then when you go to the next one, then you already know, okay, I have that answer and I'm using that answer there. Now here it says determine the value of m. So here I already know that the equation of that line is y equals to negative 3x plus 16. And this point here is also on that. You see? So now what can I do here? I can write the equation y equals to negative 3x plus 16. Then I substitute that value, the point s for an m. Then I substitute it. Then what is my y value? So my y value is going to be m. My x value is going to be 4, then plus 16. So therefore I'm going to get a negative 12 plus 16, which gives me m is equals to 4. Right. How do I know that I'm correct? Is in the first quadrant. In the first quadrant, the y value is positive, so it could be 4. The x value is positive, it's also 4. So the point of s now, it's going to be 4 and 4. So I already know the point of s now. So the point S is 4 and 4, so I'm covered with it. Then I know I am correct. So you can see the marks that we're getting there. It's 1 mark for finding the answer and 1 mark for substituting. Because from this substitution, you can go directly to the answer. We don't need that step here, okay? Right. So you can use a calculator. Please make sure you know how to use your calculator. All right. Okay, 1.2. Show that PQR is a right angle triangle. And these are some of the questions that really, and I know most of us, when you do this question, you write a lot of stuff there, and at the end you just say, therefore, PQR is a right angle. We don't mark that part that says it's a right angle triangle. We want to see how you have done it. You must understand what the question wants. Most of the time, the question that says show or prove that are a bit of a challenge to the learners. But these are easy questions because you must understand if it's a right angle triangle, what is a right angle triangle first? So a right angle triangle is that triangle that is one of its angled 90 degrees. So now you can see that this line here and that line here, they are perpendicular. So if they're perpendicular, they're gradients. When we multiply their gradients, line 1 and line 2, those two gradients must give us -1. So in other words, if I say the gradient of line 1 times the gradient of line 2, it must give us -1. So once I can prove that this gradient of line 1 and the gradient of line 2 gives me -1, I can then say, therefore, this triangle is a right angle triangle. Can you see? So you can see that we don't mark the last part. We want to see how you worked out your question on how to find those two lines to be reciprocals. Right, now let's check this. PQR, where's PQR? So it's PQR. So they say show that this thing there is a right angle triangle. Show that this is 90 degrees. So now I have the gradient of this line here, and I know the gradient of that line here. If I can multiply these two gradients and I get -1, then I can then say, therefore, it is a right angle triangle. Now, how do I get the gradient there? So first I must get the gradient of QR. For me to get the gradient of QR, remember the gradient of QR will be -2 into -4 divided by 6 minus 0. That is the gradient of this line here. So the gradient of that is going to be, so I'm going to get, let's check this. So I'll have a 2 there, and I have a 6, which is going to be 1/3. So the gradient of that line QR is going to be 1/3. How do I know that? It's a positive gradient. Can you see? It's increasing, increasing, increasing. So it's a positive gradient. So I know I am right. Now I already know the gradient of PQ because I got it the last time there. So still remember the gradient of PQ? It was -3 in the previous slides. So now, if I take the gradient of QR multiplied by the gradient of PQ, let's see what I'll get. The gradient of QR is 1/3. The gradient of PQ is -3. And if I multiply this, and then I'm going to get -1. So can you see that the gradient of QR times the gradient of PQ gives me -1, which means that that angle that is formed there will be 90 degrees. I can then safely say triangle PQR is a right angled triangle. It's a right angled triangle. Okay. So remember, we are not going to mark that step. We're going to mark first, it's 2 marks, so you can see it's 2 marks. So we're only going to mark the gradient of QR, and also for you telling us that when you multiply the two gradients, they give you -1. And the last part, we don't mark it because we've already given to you to say it is, show that it is a right angle triangle. So you have shown that. Okay. And sometimes you can't go to the sketch and draw this and say, yes, it is a right angle triangle. We can't do that. We must do the calculations. The word show that means that you need to do a calculation to show that. You cannot go to your sketch and draw a 90 degrees there and say, oh, now I have a right angle triangle in that sketch. No, you can't do that, please. Okay. The next activity that we're going to look at here, I'm going to try to give you a a minute to do this one. And please, any question that you want to ask, you can send your question to 063, the WhatsApp number, 063 629 3655. 063 629 3655. You can send your questions there and also your solutions there. For this particular question, which is an easy question, I'm giving you only 1 minute. And your minute starts now. Okay, thank you. Now, in this one, it says, in the diagram, the F point is given, -1 and 5. G is given, but it's X and Y. And the second center origin, meaning that the coordinates of this will be 0 and 0. Right? FG, it's parallel to that information is also very, very important. FG, it's parallel to the to the y-axis. Okay, so already I know we have got parallel lines. What do I know about parallel lines? When dealing with analytical geometry, the gradients are the same. So I know that now I know the gradients. Okay, right, it's a circle. So I'm fine with the circle. So now I need to find the coordinate of G, which is only 2 marks. So I'm going to use the coordinate of F to get the coordinate of G. So if I've got -1 and 5, and this line is parallel to that, so that point here, the coordinates of G will simply be, so now, there I have a -1, so meaning that that point here it's -1, so it means that the G point will, the X value of the G point will also be negative. But there I have a 5, so there I'm going to have a 5, but that Y value cannot be a 5 because 5 is on there. So meaning that that point there will be a -5. So in other words, my G point, my Y value will be -5. So I'll have a -1 and a -5. Okay, then I know that this line here and that line will be the same. They are both radii. Okay. Sorry. Now, easy question there. So the marking this point and that point. Okay. Even if you don't get the Y value correctly, but you must get the X value correctly, which is 1 out of 2, which is 50%, which is fine. You see those words are repeating again. Now they determine the gradient of OF. See, the gradient of OF. We already know that O its coordinates 0 and 0. Once you, and it's 1 mark. So the gradient of a line from the center of that circle to any other point, because this is 0, 0, and 0 minus a number is that number, and then 0 minus another, and that the X value there, it will still be the X value. So meaning that the gradient of that 1 mark must not be a problem. So what we do is, we go to F, we write the Y value on top, X value at the bottom, and the answer there will be -5. So the gradient of that will be -5. So it's 1 mark. So for giving us the gradient of that, it's only 1 mark. Okay. Want to work it out? It will be 0 minus 5 and 0 minus minus 1, sorry. So it will be 0 minus into minus 1, okay, which is going to be minus 5 over 1, and then minus 5 over 1, and then which is the same as minus 5. Now the next question says the equation of the tangent. But in this case, do I have a tangent? No, I don't have a tangent. So it means that I must draw in my tangent. And they say at point F. So meaning that what is a tangent? That line that touches that circle at only one point. So it must touch there only. And what do I know in geometry? That a line from the center of the circle to the point of contact, that angle there, it's perpendicular. I mean, sorry, the angle there is 90 degrees. In other words, the radius is always perpendicular to the tangent at point of contact. So here is my radius, there is a tangent, at point of contact, the angle 90 degrees is formed. Already if I have 90 degrees, what do I know about the gradients? The gradients are going to be the same. I mean, so the gradients, they're going to be reciprocal. So if I have the gradient of OF, I can grade the gradient of the tangent. So they say they want the gradient of the tangent at F in the form y is equals to. Please always adhere to what is given, because you're going to lose marks if you don't. So now I know the gradient of OF, which is going to be minus 5. So meaning that the gradient of the tangent, this is minus 5 over 1. So I just swap them around. So I just swap these two around, then I'm going to get 1 over 5. If that one is negative, that one should be a positive. So when I multiply them together, I must get a negative 1. Okay, so the gradient of the tangent I have. Now I need the point F, which is minus 1 and 5. If I've got a gradient and a tangent, I can write my equation y equals to mx plus c, of which my y value is going to be 5. My gradient it's 1 over 5. My x value is negative 1, and I need a c. So to work this one out, I then need a calculator. So I can just take the 5 and I add 1 over 5 and I get a c. Okay, so I've just taken these ones to this side, and then from there I get my value of c, which is going to be 26 over 5. But I'm not done, because they said I must write the equation in the form y is equals to, and that's why we lose marks, because we leave our answers at c is equals to 26 over 5, and that is not the equation of the straight line. Then we then say, therefore, y equals to 1 over 5x plus 26 over 5. And that is the equation of this line, which is a tangent. How do I know I'm right? It's an increasing function. It's increasing, 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 increasing. The gradient is positive. That's fine. That graph, that function will pass at somewhere at the positive y-axis, which is roughly going to be 26 over 5, which is our y-intercept. So you always go and check the answer that you get, and you compare it with the sketch that is given and see that it makes sense. If it doesn't make sense, go back to your calculations and check. Okay. This is also an easy question to do. Now, why am I saying this is an easy question to do? It is because it comes every year, and we do it in class, and we, in the test we get it and all that, and it doesn't change. We just change in the numbers. It does not change. This is free marks. This is free marks. Go and practice this. You're going to get free marks. These are free marks. You must get them. Let's see. On the grid, they say draw the graph. You see, draw the graph defined by that. Please, you must always try to see what you're supposed to do in there. You have got an x squared over 7. You have got y squared over 64. It's a plus sign, please. then you have equals to 1. So the answer there must always be equals to 1. Make sure. And they say clearly show all the intercept with the axis. This is 3 marks. This is 3 marks. So what do? I then say, okay, the 7 that I'm having is for the x. So here is my x-axis. Here is my y-axis. So the 7 is for the x. So what do I do with that 7? I take the square root of 7. So whatever I have at the bottom there, I'll take the square root. So my x value will be square root of 7. Remember, it was x squared equals 7 in this case. Then we just take the square root of 7. So the square root of 7, if I go to my calculator, it will be 2 point something. Okay. Then I'm going to my sketch there and I said, okay, this is a 1, this is a 2, 2 point something, then I can just have a point there, you see. Okay. Then I go to my left also, I say this is 1, this is 2, 2.7, somewhere there. All right. So I already have my x values. But my y values, I go to the y and I say y squared equals to 64. So y will be equals to 8. So my y will be square root of 64, which is going to be an 8. Then I go to my y-axis and check 1, 2, 3, 4, 5, 6, 7, 8. So 8 will be there. Remember, it's a plus or a minus. So it's a plus or a minus. Right? So I've got a plus 8 here. I need 1, 2, 3, 4, 5, 6, 7, 8. I have a negative 8 there. I'll have a square root of 7 there. Square root of 7 there with a minus. Then I just join these points and I'll have my, okay, I'll have my ellipse. So let me draw it nicely there. Then I'll have something like this. It must look like an ellipse. Okay, then that is my function and I'm done. So the 3 marks will be for the x values, for the y values, for the x values, and for the shape. And the shape must be correct. You see, there's a correct shape. Okay, so we draw it with a free hand. We have seen different types of ellipse which are really not correct. You know, you cannot have an ellipse whereby you have something like this. This is not an ellipse. Okay, this is not an ellipse. You cannot have something like that, okay, and say this is an ellipse. And we get something like this, you know, in an exam, and that is incorrect. It must look like that. Okay, so that point here, it's a point there, it's a point there, and then it must look like that. Okay, 3 marks, this is free 3 marks. Okay, so we must definitely get this question right at the end of the year, or now in the prelims. Okay. Your analytical geometry, it's done, and it's plus minus 25 marks. And you can see the 25 marks that it was not a difficult 25 marks. So already you've got 25 marks in your pocket, and you need more marks. So you need about 20 marks to at least pass that paper. So remember, your pass mark is going to be 45, but now we cannot dwell on the 45 because, you know, you plan for 45 and then you drop and then you fail. So let's plan for more marks. Okay, in trigonometry, we also going to look at the free marks or the marks that we can be able to get. And up to 50 marks, we can get up to 30 marks in the trigonometry. And let's look at this paper and see how we can get it. The first thing, candidates must be able to, so in other words, you must be able to know, to understand the basic trigonometric ratios. And take note that there are special names for the reciprocals. So in other words, remember, I've got a sine, I've got a cosine, I've got a tangent. Now I've got the reciprocals, which is cosec. We have this one as sec, and we have that one as cot. So those are their reciprocals. They've got names. Okay. You must refer to special angles, calculating without using a calculator. That's your special angles, meaning that, you know, your 0 degrees, your 90 degrees, your 180, you know, 360, and then you have your 45 degrees, 30 degrees, you have your 60 degrees. Those are called special angles. But we know you use the calculator. And if you put decimals, then we know you have used the calculator. But mostly now the calculators gives you a fraction, you leave it as a fraction. Then you use that calculator, but leave your answer as a fraction. Then we know you have not used the calculators. Okay. I know you're going to cheat with this one because we always do. But once we don't give it to the US 45, we give it as maybe 135 degrees. Then we want you to reduce it. Then from there you can, if you use tan 135 as it is, then we know you have used a calculator. Simplify trigonometric equations, expressions, solve equations there by making use of a calculator. There we allow you. Determine the solution of the trig equations for limited to routine procedures only. We'll check the question. Apply the rules, the sine, the cosine, and the area rules. You'll see and we don't ask you use the sine rule or use the cosine rule. But with area rule, we say find the area of this triangle. Then you must know if the triangle is not a right angle triangle, use the rule. Apply the trig identities. Very important. You know your tangent of theta, it's sine theta over cos theta. Sine squared theta plus cos squared theta equals to 1. That we call it a famous 1. Solve problems in 2D and 3D. Some of these questions are quite easy. You can manipulate these questions. And most of the time, we waste time on this question. Please make sure that you can do it at the end, because we waste a lot of time there, and then we leave out some of the things that we know. If there are things that you don't understand there, just move on, and then from there you come back to this question and you do it. But we're going to do some, they come very easy, like the one that I'm going to do from this paper. Okay, let's look at the exam questions, how they ask this. You see, I mean, this 5 marks should be easy for everyone. So the first 5 marks, always easy for everyone to do. Here, you're given that you use a calculator to do that. You're just substituting. We are having a P here, we're having a Q. That is given there, the angles are given, we're just substituting. What do I know about the chord? We know that chord will be 1 over tangent. So in other words, that angle there will be 71 degrees. This one is 42 degrees. Then there's a minus. So if I subtract this, what am I going to get then? So I'm going to get 29 degrees. So already I know chord, it's 1 over tan. The angle here that I get when I subtract the 2 is 29. And I just write down the answer, use my calculator, right? Because the chord and the cosec and the sec are not there in your calculator. So remember, it's 1 over something. So now it's going to be, the answer that I got there is 1,80. And you get your 2 marks. So your 2 marks will be, your 2 marks will be there for the changing of the and for the final answer. Okay. The next one here is the same thing. So I've got a cosec of theta over sec of p. I mean cos of q over sec of p. Cos of q. So what should I write there? I just substitute that cos 42. But what do I know about my sec? So sec is going to be 1 over cos. But it is the cos of what? 71 degrees. From there, I can just use the calculator. The calculator can do anything that you instruct it to do. So how do I use the calculator? I'll say cos 42 divided by 1 over cos 71. Then from there, the answer, and from there, just put it like that on a calculator, and that answer that I'm going to get there will be 0,24. So the 1 mark will be for the substitution, the 1 mark is for the changing of that, and the 1 mark there, it will be for the final answer. Simple 5 marks. You have the gadget, but you can't get the answers correctly. Let's practice these things, especially where you are given the reciprocals. Know that your reciprocals will always be 1 over something. Okay? So if it's tangent, if it's chord, it's 1 over tangent. If it's cosec, it's 1 over sine. So please practice that. That question was 7 marks, and like, yeah, 7 marks. What am I going to do there? It's 7 marks. That question was also quite very, very, very easy. This is a Pythagoras type question, and the same with the aid of a diagram. See, once they say that, then you must know that you have a diagram, you have a right angle triangle. I can use my theorem of Pythagoras to get to the other side. But first of all, you must start with the given information. You'll see how the 7 marks will work. The given information, I can make sec the subject of the formula. So I'm going to say sec of beta, it's going to be 5/3. So I've taken the plus minus 5 this side, divided both sides by 3. And they say beta is between 90 degrees and 360. So meaning that my sketch, I'm going to have from 90 degrees to 360 degrees, which means that quadrant is out. So these 3 quadrants, I'm going to try to figure out where to put my sketch. But I know sec is a friend to cos. So if it's a friend to cos, where is the cos positive in this 4 quadrant? In the first and the fourth. So the first doesn't work. So it means that my sketch will be on the 4th quadrant. Then I know sec cos, it's x over r. My x value is this one, my r value is that, my y is this. But the sec and the cos do not have a y. So meaning that I need to find the value of y. So the sec, so in this case, if it's x over r, this becomes what? R over x. So my r, it's 5. My x, it's 3. I need a y value, which is going to be a negative value. So therefore, I can use the theorem of Pythagoras to get my y value. Right? So my x value is 3 squared. My y, I don't know. My r squared, it's 5 squared. So my y value will be 25 minus 9, which is 16. And the square root of 16, it's plus or minus 4. But which one do I take? I'll take the minus 4. Reason being, the y value is in the 4th quadrant and it's a negative value. I'll then say, therefore, my y will be negative 4. Okay. So it's very, very important that you first understand from here to there. So the sec, all those reciprocals, you must learn them. You must learn them and you must know which one goes with which. Okay. So from here, the question, it's not done because I need to get this. Why did I do all these things here? I needed that to complete my sketch because I've got a right angle triangle with my beta there. Okay. So my right angle triangle, I've got a 3, I've got a 4, I've got a 5, I've got a minus 4. So for me to get to the sign, I need a y value. So I'll then say, okay, now I've got sine squared of beta minus cos squared of beta. Then I'm going to then say, okay, what is my sine of beta? Remember, sine squared beta means the sine of beta all squared minus the cos of beta all squared. Okay. Once I put a value, I must not put the ratio. So I have seen you guys doing sine, then you write minus 4 over 5. That's incorrect. Once I put negative 4 over 5, I no longer put the ratio. The ratio is already done. Okay. Minus the cos is given somewhere. It's going to be 3 over 5 squared. Then the answer, from here, take out a calculator, punch this in a calculator, then get to the answer, which is going to be 7 over 25. That's the final answer. So you'll get a mark for that. You'll get a mark for the sketch. You'll get a mark for finding the value of y. So you already have 3. So you have 4, 5, 6. Then you'll get a mark for the method of finding that. So you get a mark for the method. Get the mark for finding the value of x by calculating correctly. You get a mark for the sketch. You get a mark for substituting correctly. Okay, the substitution correctly there. I think there's a substitution also there. So you get a mark for the substitutions. So you can see we've got quite a number of marks there. The 7 marks was not very difficult. These questions are there year in, year out. Check your past papers and then try to do these questions because they come each and every year. Okay. Right. Then the trig equations, you see the one that we talked about then, to say how do I solve for x if I've got a trig equation like that? And this one was not a difficult question to do. What we need to do, what we need to understand is that I first need to write this one correctly. So I'll have the unknown on one side and I've got the tan of 29 degrees. Okay, so now I'll have, what will be the tan of 49, the tan of 29 degrees. So I must first get the tan of 29 degrees. How am I going to get that? Okay. Right, so I'm going to have the cos of 2x, then I get the tan of 29 degrees. So for me to get the tan of 29 degrees, I use a calculator, and then from there I get the tan of 29 degrees. And then from there, I'm going to use the 2x in there and say this is equals to, because then I'm going to use shift cos of whatever I got as tan of 29 degrees. Then I'm going to get that. So I'm going to give you 2 minutes to complete this question. And your minute starts now. Okay, now let's see what you got there. Now, first of all, you got the tan of 29. So the tan of 29, so it's 0,554, and you have other values there. Please remember we round off at the end when you're doing our mathematics, okay? So now we've got that. So now the 2x, how do I get this? Now the 2x, of which I need a reference angle. Then my reference angle, it's going to be, if I go to my calculator and say shift cos 0,554 and all those decimals, then I get 56.34. I'll get 56.34 degrees now. And this is my reference angle. Now I'm not done. Remember, this is 5 marks. Okay? So I already have a mark for writing that, or for transposing that, and I've got a mark for reference angle. So I only have 2 marks. Remember, I need all the angles between 0 and 360 degrees. So what do I do first? I must check this value there. That value there is a positive value. Then I check on my quadrants, where is the cos positive? See, very important there. My cos is positive in the first quadrant and in the fourth quadrant. In the fourth quadrant, I know it's 360 degrees minus, right? The reduction formula. So now I'm going to say, because I need my solutions in the first quadrant and in the fourth quadrant, I'll have a table. In the first quadrant and in the fourth quadrant. In the fourth quadrant, I use 360 degrees minus reference angle. Then the first quadrant, I don't use any reduction formula. Okay, so I'm going to say 2x is equals to 56.34. Can you see I'm using the 2x as it is? I did not divide by 2 because that will make that sum to be incorrect if I divide by 2 here. Remember, it's a reference angle, so we keep this guy here as it is. Even if it was x minus 20 degrees, we'll keep that guy as it is until at the end. From there, when I draw my table, then I'm going to say x is equals to, so I'm going to say that angle here divided by 2, I get 28.18, 28.18 degrees. Remember, these are degrees. So in the first quadrant, it must look like that. In the third quadrant, I'm going to say, the fourth quadrant, I'm going to say 2x equals to 360 degrees minus 56.34 degrees. You see? So that then I have the size of that angle in the fourth quadrant. So I'm now going to say 2x is equals to, then I subtract that angle from 360, then I'm going to get negative, 303 degrees, 64. All right, so I'm going to get that angle. Then from there is then that I can divide by 2. So I divide that angle by 2, and then I get 123. Okay, let me just quickly check here. Equals to, then I divide that by 2, then I'm going to get 151 degrees, 82. Okay, so I'll get that there. So those are my 2 answers that I'm going to have. So for me to check, I can take that angle here and substitute it there. And then from there, I see if I can get a number that is close to 0. Remember, we rounded off, so meaning that I must get a number which is close to 0. You can do it now. You can go to your calculators, say cos 2 times 28.18 minus tan 29 degrees. The answer that you must get must be very close to 0. It must be 0,00. Okay. Or you can take the x and substitute by 151,82. Then you say minus tan 29. You will also get a value that is very close to 0. Very, 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 very important question here. Remember the 2 marks, we already done that. Then writing that question, it will be the third one. Writing the correct one, the correct reduction formula, and finding the correct answer. These are the marks that you're going to get. It's 5. Practice this question. It's not a difficult question. As long as you know your cast diagram, and then you are able to can check where is the cos, sine, tan, positive or negative, in which quadrants are they. Then you use your reduction formula. Remember your reduction formula, 180 minus, 180 plus, 360 minus. Okay. All right. Now, another question that really, really, really easy pickings, easy marks. You have your identities. The chord must change to what? So it's either I'm changing it to 1 over tangent, but here I can see I just need to change it to cos squared over a over sine squared of a. Because the tangent changes from sine squared a over cos squared of a, right? Then I'm done with this question. See, sine squared a plus cos squared a multiplied by over 1 over 1. I'm done with this question. That question is done. And that's an easy 4 marks. So knowing that my chord angle can be changed to cos A over sine A, knowing that the tangent is a reciprocal of this one, so it must be sine A over cos A. If it's squared, that must be squared. So from here, the sine squared cancels out sine squared, the cos squared cancels with cos squared. I'm left with cos squared A plus sine squared A, and I can hear you saying that is a famous one. So we call it a famous one, the famous one, this one. So we have the answer as 1. So the marks there, 1 mark there, 1 mark for changing that. Nice. Then from there, 1 mark for manipulating that. Then the final mark will be for the final answer, which is 1. Okay. Quite an easy question, this one. Right. And these are questions you will get in the test. So when you see a tangent, just change it to sine over cos. When you see sec, just change it to 1 over cos. When you see cosec, just change them. Just change them, and then you get a mark for that. But just for changing them, you get a mark for that. Okay. This is 9 marks, and it looks very difficult. But you'll see how easy this thing is and how easy it is to mark there. And you're thinking, this space is so small to write down all these things. No, 1 line, you'll find that you get 5 marks out of only 1 statement, 1 step. Now, it says prove that this is equal to that. It means that I'm not using that. I'm only using my left-hand side for now. Now, look at this. Pi here represent 180 degrees. My pi here will represent 180 degrees. And I'm done. So I'm having my reduction formula 180 degrees minus 180 degrees plus 360 degrees minus. I'll leave it up there. So I'll have CAST. Okay. Now, if I've got this sketch, I'm able to do this whole sum. I can get up to 6 marks out of 9, which is good. Okay, so now let's see. 180 plus theta, I go to my sketch. 180 plus theta falls in the 3rd quadrant. In the 3rd quadrant, the sign is negative. But because of this squared, it becomes what? Positive. So meaning that I just write the sine squared of theta. And then I get 1 mark. Okay, so you can see how easy that thing is. I said 180 plus in the 3rd quadrant. There's no S in the 3rd quadrant, meaning it's negative. But because of the square, it becomes positive. Right, and I put it inside the brackets. And I'll say plus. I go here, 180 degrees in the 2nd quadrant. In the 2nd quadrant, it's cos it's negative because there's no C there. So it becomes negative. So there's no square, so it will remain negative, then becomes negative cos of theta. Okay, right. The sec of 360 degrees, sec is a friend to cos. So 360 degrees minus, it's in the 4th quadrant. In the 4th quadrant, the sec and the cos are positive, meaning that that one will be sec of theta. I know sec must be changed to cos, 1 over cos of theta. So already I've got 2 marks there. Because I've already changed it from 360 minus to theta. Then from there I also changed it from sec to cos. Then I'll have tangent 180 times 2 is 360, meaning it's tan of 360 minus. 4th quadrant, there's no t. If there's no t, it becomes negative tan of theta. Multiply by cot 180 degrees plus. So 180 plus cot is a friend to tan. So if it's a friend to tan, then it becomes a positive. So it becomes a positive cot. But I know cot is 1 over tan of theta. So already I've got a mark for that. I already have a mark for that and another mark there. So already you can see I've got 1, 2, 3, 4, 5, 6 marks. I've got the 7th mark here. So already I've got 7 marks in that step. Once you practice this, you'll have those marks. Those marks are free marks. Then from there, what do I have? the sine squared, I'm going to leave it like that. The cos and the cos will cancel out, meaning that I'm going to be left with -1. The tangent and the tangent cancels out, I'm left with -1, which means then I'll have negative sine squared theta. Negative and negative is +1, which gives me 1 minus sine squared theta. From the famous one, you can still remember from the famous one, which is cos squared theta plus sine squared theta, it's equals to 1. Then I'll have cos squared theta, it's equals to 1 minus sine squared theta. So for this, I can write that. So I'll have cos squared theta, and that will be equals to the right-hand side, and then I have that. Okay. Okay, but up to here, we already have 7 marks. And the 8th mark will go for the manipulation of that. So the 8th mark will be going there, and the 9th mark will be going there. To writing it in that form, or just to manipulating the whole thing there. Okay. All right. So you have 9 marks, and that question is not a difficult question. Once you have this sketch here, you are able to can do this question here. Okay. The next revision exercises will also be showing you how to cheat it a bit with the calculator. Okay, but for now I want us to do it like this. Practice it, and then we can show you exactly how to do it again if you are struggling. Question 5. Its functions, very easy. Also, calculator usage, very important. You must know how to use a calculator here. So you're given this function and that function, and they need a period of g. So the period of g, how am I going to get the period of g? So because I know it's a cos graph, the period of the whole cos graph is 360. That is the period of this graph. Okay. But because there's a 2 here, so we're going to say that divided by 2, and it gives you 180 degrees. So if it was 3 there, I'll divide it by 3. If it's 4, I'll divide it by 4 to get the period of the graph. That's 1 mark. Okay, easy marks. If I had a 1, if I needed the period of that, I have 1, so it was 360 divided by 1, which is 360. Okay. Here they say we must sketch the graph of y equals to sine x and y equals to cos 2x. So you just take a calculator. And from there, because the period was, for this graph was 180, I just take the period of that graph, divide it by 4 quarters. Remember, we've got 4 quadrants. And then I'm going to have 45 degrees. And then it means that my intervals there are going to be 45, 90 degrees, 135, 180 degrees. See how we can get, so that we don't put 90, 180, 30, because now our graph there will end at 280 degrees. Okay, right. So if you check backwards there, they said we must draw that graph from 0 to 180. So now it's up to 180. So we've got a 0 there. Okay. So you take a calculator. Please do not complicate your lives. You take a calculator, you put all these values in here. You can even draw a table like this. And then from there you have all the values, your x values. And from there you can have your graph sine x. You can have your graph cos 2x. You substitute. You first substitute by 0, by 45, by 90, by 135, by 360. Or you can use your calculator and just put those 2 graphs together. Then you are able to can get the points. Your step will be 45, so that then you get all your points. Okay. So if I substitute all these values, this is the graph that I'm going to get for f. So I'm going to get at 0, and I'm going to get that one at 45. Okay, so I'm going to have that one as 90 degrees. I'm going to have it as 180 degrees. So my graph will be somewhere there. So I'm going to have a graph like this for my F graph. So my F graph will look like this if I put all the points together. Now my G graph, if I put my points together, I'm going to start here at 1. My graph is going to start at 1, goes there and goes there, and from there it goes there, and here I don't have an arrow. If you put an arrow, you're going to lose a mark for the shape. These graphs, they stop here, so they don't have arrows. So I've got an F graph here, I've got a G graph here. You must name your functions. Okay, and I must write down what is that point there. It's 90 degrees and 1. This point here is going to be 90 degrees and -1. So those are my turning points of the graph. And this, you get full marks there. I think it's 6 marks on the question, 6 free marks on that question. Use your calculators correctly. You can use a table to draw that graph. You can use a calculator to get all the points. Just put the points together, and then you have a lovely graph like this. Okay, don't just draw anything there. Please, you have the points. Just say sine of 45, then you'll get that point here. Just say cos of 2 times 45, then you're going to get that point there. So therefore, you draw your sketch properly. So practice these types of graphs. Right, these are the questions that we're talking about. I'm not going to waste a lot of time on this type of questions, but I'm just going to quickly show you how we can then quickly look at how to answer these questions. That whole story there, you must then look at if all the values that I put there are in the sketch. You see, the 481 is there in the sketch. The 90 degrees is indicated. The height is indicated. The 23 degrees is indicated. The 33.9 degrees is indicated. And this line here and that line are equal. And what do we call that triangle? Isosceles triangle, which means that that angle also will be 33.9. I need that angle here. So to get that angle must be easy. 180 minus this angle and that angle. Then my size of PRQ will be nothing but, if I subtract all these angles, I get 112.2 degrees. See, and that is the 2 marks, easy 2 marks. First, you must write down that one, then I know that is 112.2 degrees, because these 3 angles must give me 180 degrees. Okay, now the next question, determine RQ, the distance between the observer. So in other words, I need RQ. What do I already know? I know that this is 33.9, this is 112.2, and this angle here, it's opposite that angle, that line, and it's given. Nice. The RQ, it's opposite that angle here, and I know it. So I can be able to use the sine rule here. See, so I can say sine of 112 degrees, 11.2 degrees, sorry, divided by 481.1 equals to the sine of 33.9 degrees divided by RQ. So I can then get RQ, it's equals to, I can just manipulate that, and I can multiply this one by that and then divide it by this. So I'm going to say 481.1 multiplied by sine of 33.9, all divided by sine of 112.2. And I quickly use my calculator to get the value of RQ. In this case, the value of RQ, if I calculated it correctly, it's 289.81. You must remember to write down the units because that's in meters. So that's the 3 marks for writing the sine rule correctly, making RQ the subject of the formula, getting to the final answer. So, and that is a right angle. So that's why you use your rules, because that triangle there, it's not a right angle triangle. Okay, right. Okay, the next one, the value of H. The H, it's there. Can you see it's in a right angle triangle? You see it's in a right angle triangle. So if it's in a right angle triangle, I use my ratios. Do I know what is RQ? Yes, I got it. It's 289.81. Can you see? When I'm doing these questions, I must then also put in the values in them. Okay, so how do I determine the value of H? I see if I use this angle, I've got the opposite and I've got the adjacent. What uses opposite and adjacent is the tangent. So as a tan of 23.5 degrees, it's equals to h over 289.81. Then the h will be the same as 289.81 multiplied by the tangent of 23.5 degrees. Then I'm using my calculator to get that, and I get 126 meters. And they say to the nearest meter, meaning that I don't have decimals, so my h will be 126. Okay. Right. Now, determine the area of QPR. Then they ask you the area. You see, with the area, they will ask you. So the area equals to half of this side times this side multiplied by this angle, sine of that angle. So I already know what is this side. It's 289.81. This side is 289.81, the same. So I'm going to say half of 289.81 squared, because these are the same. All right? Multiply by the sine of 112.2 degrees. Then I just use my calculator, just 2 marks. So there's not much work to do there. So this line times that line times half times the angle which is included. Remember, it must be an included angle here, okay, between the two lines. So that's multiplication sign. So the answer that I get there is 38,882,53. So remember, it is in meters, so it's meters squared. Don't forget to write the units, it's very important. Okay, so this question, you must attempt it. This type of questions, you must attempt it. Because we don't do a proof there. We just want you to write, to understand that if it's a right angle triangle, use the ratios. If it's a triangle without a right angle, use the rules, the area, the cosine rule and the sine rule. The area rule, we only use it when we are given the area or when we are requested to find the area. They will say determine the area of the triangle. Then if it was the area of the right angle triangle, we know that we have the height and we have the base. We can then use half base times height. Okay. Please attempt these questions. Now the Euclidean geometry, you must know in this topic, you must first know all your theorems, your grade 8 and 9, the basic ones. Then from there, you must understand your grade 11 theorems, all your grade 11 theorems. 9 theorems, please, you must know how to state those theorems, and because you have that 1 mark for stating the theorem, and then you must also know how to apply them. You don't need to know how to prove them, you just need to know how to apply them. To say this angle equals to that angle, the reason is tan perpendicular to the radius, or it is angle between the tangent and the chord, or it's angle at center is twice angle at the circumference. You know those reasons, you must just know them. They are there in the exam guideline. So when you are practicing your trigonometry, your Euclidean geometry, go to your exam guideline and practice, and you put it here next to you, and then from the page through when you're doing your Euclidean geometry, so that then you check which reason goes, which statement goes with which reason. Here it says complete the following theorem. It's always there. This question is always there on stating that, or on completing these theorems. We'll give you the statement, but then we'll just take out some words there. So it says the line drawn from the center of the circle to the midpoint of the chord is, and we have seen very interesting answers there when we were marking there. You know, Lena saying that is equal. It's, you see, that theorem is a theorem number 1 that says a line drawn from the center of the circle to the midpoint of the chord. Midpoint of the chord. What does it do? It is perpendicular to the chord. So in other words, the answer there was perpendicular to the chord. Perpendicular to the chord. That's your 1 mark. And you must always, if I learn these theorems, I'll always get a mark for this. Okay, I'll always, if I know all my, especially the grade 11 ones, I'll always get a mark for that. Okay, right. And if you know how to apply them, you'll be. So the next question will always be the application of what you have been asked. You see, the line from the center of the circle to the midpoint of the chord is perpendicular to the chord. Can you see? The application there will be based. So if I were you, I'll first check the next question, and then from there I check the theorems the writer that is given, and then go back and say, oh, they've given us this, then I can be able to write down the theorem that is given. Okay, now quickly it says determine the length of OM. The length of OM is 1 mark. You are given that AP is 16, so from here to there it's 16 meters. Then you are given that PB is 4. So it means that the whole diameter from there to there is 20. So AB is a diameter, it's 20 meters. Therefore, OM is a radius. And what do you know about the radius? The radius is half of a diameter. So therefore, OM will be 10 meters. So that's the 1 mark. 1 mark there, just for writing that. Okay, the next question obviously will say, stating the reasons. The length of MP. So if I take MP there, what is the length of MP? I already know that this is 10 meters. Okay, and I need to find the length of that. But I already know that the line from the center of the circle to the midpoint of the chord, it's perpendicular to the chord. So that's the reason that they're talking about here. So, which means it's perpendicular to the chord. So, which makes this a right angled triangle. Can you see it? Okay. Then how do I get OP? I know that the whole length there, it's going to be 16. But I know that my radius from A to O, it's 10, which leaves this one to be how much? 6. So I can then get the length of the other side by using the theorem of Pythagoras. So I'll say MP squared, it's equals to my OM squared, which is 10 squared, minus 6 squared. That gives us 100 minus 36, and that will give you 64. MP will be equals to 8 meters. That's 5 marks. Is quite an easy 5 marks, okay? But remember the reason there, they need a reason for that, okay? The other reason will be the theorem of Pythagoras. So we need reasons there. Okay. All right. Okay. The last question that I'm going to quickly look at, it's the question which most of us think is very complicated, and it is not. Because I can first work with my sketch without looking at this. So I'm just going to work on my sketch without looking at the answers, the questions, sorry. So first of all, I read my statement, and from there I can see this line here, it's parallel to this line here. What do I know about parallel lines? That angle here will be equal to this angle there, because they're parallel. It's alternate angles. I can see I've got a CH and HD as tangents from the same point, so these points are equal, meaning that this angle here, it's equal to that angle there. So this is 37, meaning that that angle will also be 37. You see, I'm working on my sketch without looking at the questions. So I can complete CDH. 37 plus 37 gives me 74, and then 74 from 180, I can subtract 74, then I'll get 106, meaning that this angle here, it's 106. If it's 106, I know H1 is going to be 74, and I must be writing the reasons, okay? On the side, I'm writing the reasons. So I've got that one is 74. I can check this one, 74, 37 plus 37 is 74. It's an exterior angle of a triangle. Okay, so now I can quickly go to my questions. Then I know that this is going to be, there's an angle here at 37. This angle must be 37, reason being the angle between the tangent and the chord. You see that the chord equals to the angle in the alternate segment. So already I have H1. My H1 is now going to be 74. and that reason will be exterior angle of a triangle. Because I already got this one and that one, it's given, so I can just add the two. Okay. The next question there, 8.2, the last one, it's C2. So I'm going to go back to do it on the same sketch. C2, I already have C2 because I already have F1. F1 and C2 are the same, so meaning that they are alternate angles. So C2, it's equals to 37 degrees because C2, it's equals to F1. And F1 there, it's equals to C1. So I'm just writing these statements like this for space. So I can be able to get it. So if I work on my sketch and writing the reasons down as I get the angles, then I filter out what I need and write it in my answer book. And that's how we can do your geometry. So use the sketch, get all the angles you can, then from there you are able to get there. And I want to say, keep practicing. Take past papers. Now it's no longer time for your textbooks and stuff. Take past papers. Practice with past papers. And you'll see what we have been doing here. It's exactly similar to what it's in other papers, because I've taken this from the past papers. And I want to take this opportunity to say thank you so much and good luck in your prelim examination. You only have a week, and go and practice. And I hope and trust you'll get these things right. Thank you so much. Enjoy your day.